Welcome back, Math 20-2. Up to today, we have done in the statistics units, we looked at our averages, we looked at our distribution from the mean, which is a type of averages, and we just mostly did number crunching, figuring out what everything means, and everything like that. Now, finally, we're getting to the interesting stuff, which is word problems. And we're going to apply everything we've learned about the standard normal distribution and the curve, the bell curve, to real-life situations. Our first example here is looking at a light bulb manufacturer, which produces 35,000 light bulbs. Now, in business and factories, they constantly are using distribution to figure out warranties and stuff like that. So here we go. We have a light bulb manufacturer produces 35,000 light bulbs. Now, out of these light bulbs, over the past, they probably have done research because it makes sense. Otherwise, well, if you don't know your product, you're not going to sell. So they've probably done research, and they found out that the mean is $900 per light bulb. That's our mean, is $900. Okay? So we have 900 as our mean. They also know that there's a standard deviation of 50. Okay? So 50 hours. So every 50 hours is the standard deviation. So that's how they spread away from the mean. Okay? Now it says, predict what percentage of the bulbs will be between 825 and 875. Well, as soon as we look at this, we're trying to predict the percentage, or if it says area under the curve, we know we must use the z-score. But in order to find out z-score, what do we need? We need to know how many standard deviations they are away from the mean. So we're first going to look at these here, and I'm going to say, are these above the mean or below the mean? They're both below the mean. They're both going to be on this side of the graph. So let's first look at 825. That's quite a bit away. And then we're going to look at 875, which isn't quite as much. Okay? Now we're going to look at our trusty formula for the z-score. Our z-score is equal to our point, any data point that we want, the one we're looking at, subtract the mean, all divided by my standard deviation. So let's take a look at the 825. So the z-score of 825 is equal to 825 subtract 900, which is my mean, all divided by a standard deviation 50. So we want to know how many standard deviations away from the mean. So how far away is it from the mean, this one, compared to the rest? Well, 825 minus 900 is negative 75, divided by 50 is negative 1.5, 1.50. So now we can find the standard deviation, or the probability, or area under the curve for that. That's just my z-score. Okay? Let's try the z-score for the next one. We also need the z-score of, in order to find the area, because we want the area in here between these 2 points, because it says everything in between. Okay, so we want the area between those 2 points. We're going to look at the z-score of 875 subtract 900, all over 50. I do my calculations, that's going to give me negative 0.5, because 25 divided by 50 is 0.5, and it's on the negative side. Now looking at this graph, what does the z-score mean? When we look up our z-score in the tables, it's going to tell us everything left of 875. Look at that one. And everything right of 825. Well, we want everything in between them, right? So that is going to be we want everything between these two z-scores. So this is actually this is 0 for my z-score. This here is going to be negative 0.5, negative 1.5. So we're looking at the probability of getting between negative 1.5, and it must be greater or equal to negative 1.5, but less than or equal to negative 0.5, 0.5. If you wanted, you could have used these tables here, 825 and 875. So we look up in the z-score the probability of each one of those, because basically we want the area under for 875, and that will tell us everything to the left of 875. Subtract the area under the curve for, that's everything left of 825. Okay? Now we look at these here. I'm going to get my area for this is going to be 0.3085. Remember, we just looked back in the book at the table, and we're going to subtract 0.0668. And altogether, I am going to get 24%. Okay, so 24.17% are going to be there. Now my next question says, how many of the 3,500 light bulbs are expected to last between this range? Well, if we look at it, that's not much. Only 24% are between there, and there's this many bulbs, so I'm going to go 35,000 multiplied by the 24%, which is 0.2417. All right? That's going to give me approximately 800 or 8,460 bulbs. All right? Now, let's look at C. C says determine the probability the bulb selected will last less than 920 hours. So the mean, once again, is 900. 920 hours is going to be somewhere right of the mean. But do we know how many standard deviation? No. So when we find the probability, we're going to have to first find the z-score. So I'm going to go, the z of 920 is equal to 920, subtract from my mean, because we're trying to figure out how far away it is from the z-score, all divided by my standard deviation of 50. So how many standard deviations away? That's going to give me 2 out of 5, which is equal to 0.4 standard deviations. So this is only 0.4 standard deviations. And it says we want everything less than that, so we could just look up 0.4 on your chart, and we're going to get the probability is actually equal to 0.65 and 54. So there we go. And that's how you're going to get that. Okay, we're just cruising here today. We're already halfway done. So a study shows, this will be our second last, well, this will be one of our last questions. I'm not going to do all the questions, I'm going to do most, but not quite all of them. Alright, so here we go. It says, a study showed that the mean of a certain flu virus was 12 days, with a standard deviation of 3 days. So my mean is 12 days. So this is 12. That's good to know. Alright, and that is my mean. Right there is 12. And my standard deviation is 3 days. Okay? If the data normally distributed caught in the strain virus, so we want to determine, and so on and so forth, we want to determine the probability to the nearest hundredth that it lasts 17 days. Let's look at this. 17 days. Probability to the nearest hundredth. So 17 days, is that bigger than 12? Yes. So it lasts longer than 17 days. Well, how far is that away from 17? We have to figure that for probability, and we want everything over here. So I'm going to go, and we are going to look at the z-score for 17 is equal to 17 minus 12, all divided by 3. That's going to be 5 over 3, which is equal to 1.6. Oops, 1.67. All right? Because 1.666 and around 1.67. Now, we want to know the probability of everything on this side. Now, if we look at our z-score table, it's going to show us the probability of everything this way, less than. We want everything greater than. So to do that, I'm going to go 1 subtract my probability of 1.67. Okay, so we have to go 1 subtract that probability or area of 1.67. So what we're going to find out is we go 1, and what is the probability of that, or the area? I ended up getting 0.9525. Okay, so 95.25 percentage of the things are going to be less than 17 days. So 95.25%, 95% of the people will last less than 17. So how many people will the flu last longer than 17? We go 1 subtract that, and I'm only going to get 0.05, which is the same as 5%. So only 5% of the people, the flu will last longer than 17 days. And that's how well that normal deviation helps us and to predict where you fall and if you're healthy or not, pretty much. Okay, so between 13 and 15 days now we want. Well, 13 and 15. 13 is above the mean, means 12, 13 is there, and 15 is here. We want everything in between, right? So first, what must we do? Here's 13, here's 15. We want to find what is in between 13. So we have to find the z-score of 13, and we have to find the z-score of 15. Okay? So what is the z-score of 13? The z-score of 13 is going to be 13 minus 12, all divided by, my standard deviation is 3. That's going to give me 1 over 3, which is 0.3. Okay? Now we're going to look at the z-score of 15. All right? Well, that is going to be 15 divided by, 15 minus 12 divided by 3, which is equal to 1. Ah, that's easy. I know that's 34%, 34.13, because we've done lots of stuff with that one. And everything less, that's 34 from the mean, so we look it up, and you're going to end up getting 62.9 or 84.13. It's 84.13, everything less. So we go and we want to know this. So we have to go, now for this one's a bit different one. Everything less than this, right? We're not using. So we're going to go this, subtract everything less than that. So once again, we're going to go the Z1, the probability of Z1, or Z15, subtract the probability of Z13. So that's going to give me, we looked up each of these, this one was 0. We know the z-scores. So we want to look up, we use our tables to find out the probability of each. I'm going to get 84.13 for this percent. And this one here is going to be, we subtract, I'm going to get 62.93. So now after my subtraction, what am I left with? I'm going to be left with 21%, or 0.21 is your answer. Okay? 21%, or 0.21. Because the reason why I have to subtract is 15 says everything here, and then we're missing from 13 on, so we want in between there. Alright? Okay. Alright. So our next question here is a little bit different. We look at this as talking about some toasters, but they alter things a bit. It says, right here, we know the toasters, the mean, the average life is 4.2, so this is 4.2. The standard deviation, sigma, is equal to 0.65. So 0.65 of years is standard deviation from the mean. So they're fairly accurate. You know, the average is 4.62. Very, very going to have something last a year longer than 4 or a year less, right? So then it says, we want to know, the company does not want to replace anything with a warranty of 8% of the toasters. So 8%, they're only going to look at 8%, okay? So the company does not want to replace under warranty more than 8% of the toasters. So what selection are they going to use? So they last 4.2 years. And a lot of people do this. A lot of times you guys probably have bought something and you got the warranty, and then as soon as the warranty runs out, 2 months later or a year or just a little bit later, the machine stops working. Well, this is what they do. Companies don't want to give you the warranty and use it all the time, because then what happens? If you're always using the warranty, they lose money, they go out of business. So that's why they do these little distribution charts. Let's take a look here. So we want 8% only. So they're probably going to use the bottom 8%. So that there is 8%. So in this case, we're given the probability. And we want to know, it says here, what warranty to the nearest necessary year should the company offer? So what year should they offer the warranty? We know the probability. Well, in order to do that, we have to figure out how many z-scores away they are. We're trying to find x in this case. And same situation, we're just working in reverse of what we did before. So we're working in the exact reverse of what we're doing here. Here we want to find the percent, and we're given our x's. Now, we are given the percent, and we're trying to find our x's, right? So step one is look in our table. So we go to our tables and figure out where 8% is. I know it's going to be down here, something close to 8%. It's anything like this. I could say 0.317, 0.31, or 3.16, 3.17. So it's somewhere around there. It's 3.16, 3.17, negative 3.16. Oh, sorry, that's not 8%, that's 0.08%, isn't it? So we want 8%. Here's the closest. I think, nope, that's 0.8%. So we want 8%, second decimal. 8%. Look here. This 808 looks fairly close, doesn't it? And then 793, 823. Well, which one's closer to 0.8? 793 or 808? I'd say 793. It's only 3 away. So we're going to look at the z-score of, go over, negative 1.41. So my z-score is equal to negative 1.41. Okay? Because we want everything this side. 8% is the max. We'll look in reverse. Well, we know that's the z-score. We want to find x. So what are we going to use? Our formula. We have x minus mu all over my standard deviation. Well, we know, I'm going to go back up here. So we know we have 1.41 negative is equal to x. And then we're going to subtract my mean, which is 4.2. And all of this is going to be over standard deviation of 0.65. Okay? Now, what must we do is, I'm going to multiply everything by 0.65 and just solve for x, and then add 4.2. Okay? Then we add 4.2, and I'm going to end up getting a year of, we get x, once we solve that, is equal to 3.28. Okay? So we're going to say 3 years will only be, they will give a 3-year warranty for their toasters. And that means actually less than 8%. It's probably only going to be around 7%, maybe even 6%, but less than 8% will have a warranty. So they say 3-year warranty. I've never really seen a warranty that says 3.28 years or 3.3 years. That just doesn't happen. So you just say 3 years. Okay? The next one here, I'm not going to solve all the way, but I'm going to start off for you. So once again, we're given a percent. Okay? This is just what I look at first. First, percent. Ooh. And then we have farm had a mass more than 163 grams. Okay? So 60, oh, this one we're given the x. Okay? So we have 62.3%. So that's going to be past the mean. So that's all of this. So 62.3% of the shrimp harvested, okay, had a mass of more than 153. Oh, that's more. So 153 is somewhere over here, or 135 is somewhere over here. And 62% is more. Because remember, the mean is 50%, 50%. So we want all of this. We know that is 62.3%. So then it says, if the data normally distributed and the mean of the mass is 146, oh, we do know the mean, 146. It says determine the standard deviation to the nearest 10. So now we're trying to find our standard deviation. Well, how do I do that? Well, let's look at what we know. We know this here. Do we know the z-score? No. We know percent. We have to find the z-score. So we're going to, but which side is it on? It's on this side. We want to be on this side. So I'm going to go 1 minus 0.623. Okay? And that will give me my z-score, my area under the curve I want, because we always want everything that way. Alright? So what am I going to end up getting when I go 1 subtract that? I'm going to get 0.37. It's going to be around 37.7%, so 0.3770. Okay, so that is my area of 135. Okay, it's equal to that. So now we use our trusted z-score, and we're going to find out what that equals. So we go here, and it's going to be in negatives because we want, what was it? 37.70. So 37.70. Find the closest one possible. Oh, down here, 37. No. Well, we have 37.4 and 37.8. 37.8 is closer, so we're going to use negative 0.31. So my z-score is 0.31. Okay, so now that we found our z-score, we plug into our formula. I'm going to end up getting 0.31 is equal to, we know my data point is, and that's negative by the way, my data point is 135, and we're subtracting 146, and that's all over standard deviation of what we're trying to figure out. So now we have to isolate for the standard deviation. So just cross multiply, solve for the standard deviation. Okay, here we go. Last question before your assignment. It says, the marks of a large number of students have been represented in a standard curve. So here we have our curve, and these are the marks. Now, how many students are represented under the standard curve? So how many students altogether? Well, there's 1,250, which is from here to here. This half here is 1,250. Well, I just said half, so what is that? That's going to be 50%. So there are 2,500 students. Okay, so once again we're looking at percentages, but this one was a little bit easier just looking at it. Next one is determine Z1 to the nearest 100. Z1 to the nearest 100. We have our population, but I don't have my percentage. Well, I look here, we had one like that before over here, where how we found the population, right? So we're going to divide it by the total amount of population will give us our probability. But whenever we're doing Z, Z wants all of this, doesn't it? So we're going to have to go, and this whole half here is 1,250. And we're going to subtract 452. Okay? We're going to subtract 452. And that's going to give me how many students are in that section. Or another way I could do it, that's one way, and that's going to give me how many students. So I'm going to go $798. Then I have to go 798, and we divide that by 2,500, and that will give me my percentage. Okay, so that gives me my percentage. And then from this, I could find, I'd look up, and I'd look up my z-score from that. Another way I could do it is, I know all of this is 100%. I could go 1, subtract, or sorry, I could go not 1, I could find the percentage of this, 2,500. I could go 452 plus 1250, and that gives me all of those numbers, which is a total of 702. So we have 1702 out of 2500, and that gives me a probability, and then I go 1 subtract 1702 all over 2500, and that will help get me the percentage as well. That's another way. And then once I get that percentage, I'm just going to look it up in my z-score, find the nearest z-score that's close to that area under the curve, and that's my answer. I hope you understand this. Good luck tomorrow with the assignment, and I'll see you tomorrow. Make sure you have a question ready for me.